Hey guys, I want to walk us through some basic pre-processing right now. Now this is called a PSD plot. This is basically the power spectral density, which means the relative strength of all the different brain waves at any given location in the brain at a given time. And we have another one called a PSD topo map. Now this not only shows you, you know, the same thing as the previous plot. It shows you based off of the locations in the brain and the individual frequency bands. So this is delta, theta, alpha, beta, and then what would this one be? Can't remember. Maybe that was gamma. So yeah, just confirm. So we have a cutoff at 40 hertz. So we should be covering a little bit of the gamma waves at that high. So let's go back to our code, and I'll walk you through this a little bit. So this code is supposed to generate plots for every participant. So not only does this loop through this whole directory and find every EDF file, but this also loops through every EDF file, applies all of the pre-processing we mentioned earlier, except for interpolation, because we would have to interactively select the bad channels, which we can do. It's simply not implemented in this code. So we're opening every file and then going through and plotting all the different events. So I'm just going to run this code here to give you an example. And what I've done is this code will save all the important variables and arguments, parameters in the file names, so we know the exact code that generated these plots. Also, the code saves a copy of itself into the output folder, and the name of the code itself is going to have a lot of these parameters, variables, and everything in the file name. So we should always be able to determine what code works to generate which kind of graphs, and what code generated any given set of plots, right? So this is going to go through every participant, and you can see we're generating new directories here for every participant. Every participant, of course, the file name, the first 6 digits of the file name are the participant number. They're all randomly generated when we run the experiments. So I can stop this code right now. This is just as an example, right? And it's very useful to visualize differences or changes in the output, right? So this generates all of the plots separately. Now I've created this different code here. This code is called combine plots. What this is going to do is it's going to go through all of those folders, find the file names that end with PSD topo map. You can see right here the relevant files end with PSD topo map in the file name. And we're going to take those and we're just going to smash them together so that we can compare all of them in one picture. So let me run this code right here. You can see it's working. So let's see what's going on. Let me clear this output so I can tell the new output more clearly. Okay, we've got here. Let's see what it's doing. Yep, it's should be saving everything. Oh no, the wrong code. I did not mean to run all plots again. What I meant to do was combine plots. So here we're going to combine plots really quick. This loops through all the folders, opens every plot, and it'll combine them together, hopefully in order. So we can see right here all of the plots that was successfully able to combine. We should have, let's see where it saves that. So all of these combined plots are saved to this file, combined PSD topo map. So we can see the category of video, right, for every different PSD top I'm at. So we can see here we had a big change as soon as we switched to ASMR, although that was somewhat the case up here, but we can see the activation in the different areas, right? Especially depending on the brainwave. Theta seems pretty relevant. Also, in some emotions, what is this, gamma? Gamma seems pretty relevant, even though we are cutting off the last 5 hertz of that brainwave. So yeah, these should be all of the really basic pre-processing methods available through MNE. There's countless other ones as well. This is just a very brief, quick introduction and workflow of analyzing all of our data with the methods we currently know how to use. Yeah, thanks for tuning in. I hope this helps. Please let me know if you have any questions or concerns, and we'll try and cover them and fill in the gaps of any information that's missing in this video.